And boom. What's up, Jeff? How's it going?
Ah, I'm ready to talk about lasers and death rays. Thanks for calling, Travis.
Yeah, of course. I mean, that's what you do. You talk about lasers and death rays. You wrote a book on it even.
Right, yeah. Well, I've been writing about lasers for a long time, and this laser idea of lasers as death rays has been around, uh, in fact, actually since before the laser was invented in the sense of making it work.
hmm Yeah, it's crazy how it's always interesting that it's such sort of like a there's the real stuff that actually exists and then all the science fiction and they kind of, they kind of go together a little bit.
Yeah, they've got kind of merge into a little quasi-reality, and sometimes it gets a little less real or more real. It's like quantum mechanics. It's a little bit of unreality in it.
hmm Yes, very true. So I mean, how do we even so you have like, kind of this interesting kind of field crazy study that you have done. So how do you kind of when someone asks you what you do, what do you tell them? What's your answer to that?
Well, for the book, I went back and started looking at what started as a myth or started as a tale of Archimedes, the famous Greek scientist and engineer. Uh, this story has been known since around 1200 AD. There's no record of it existing before, although Archimedes was living around 2000 BC,
hmm
which is another curious factor. Now, certainly things have gotten lost over the past couple of millennia, but why don't we know anything about this happening earlier? In fact, we just don't know all that much about Archimedes. We're just not
hmm
even clear he actually jumped out of the bathtub and shouted Eureka and ran around down the street naked when he figured out a problem. But there are these stories of him uh, doing a number of military things. And it was pretty clear he was a military engineer and scientist. And so the story goes that Archimedes, who was living in the Greek city of Syracuse, when the Romans came and were trying to just conquer the city, they were besieging the city and the harbor. Somehow he got used some burning mirrors, which would probably have been polished soldiers' shields,
hmm
and set the ships afire that were sitting in the harbor.
Right.
No, we don't have any particular details, but it's an intriguing tale. And, if you've ever played with a magnifying glass in the sun, you'll know, yeah, you can use sunlight to burn things. You can burn holes through paper. So this sort of makes sense. And since at least the 1700s, scientists have actually tried to duplicate it. Uh, there was a French scientist back in the late 1700s, and he claimed he made it work. Other people later on claimed it wouldn't work. And of course, then Mythbusters got on it more recently, and Mythbusters said it wouldn't work, and they proved it wouldn't work. And then MIT decided they'd try it themselves, and they made it work.
Huh.
So there's a picture of uh, these this model of a wooden boat that's starting to catch on fire from the light. Once the sun decided to finally cooperate here at MIT, I'm based in the Boston area, so sometimes we have more weather than others. And the first few times they didn't get any enough sunlight, but finally they did, and they ignited this boat. So what really happened? Well, you get different results with different test conditions in any scientific experiment. And, the Mythbusters wanted it to not work. And there's ways you make sure it doesn't work. And MIT wanted it to work, and they tried harder. So it worked. But really, we don't know whether this whole thing ever happened at all. It's
hmm
an intriguing story, and it's somewhere at the level of plausibility.
hmm
And there's a lot of the whole science of the whole efforts to make laser weapons or beam weapons or directed energy weapons falls into that category of, well, it seems like it should work, but will it really work?
Yeah.
And that's the way this thing has gone on for a long time. So in the back around 1900, there were a lot of scientists who were discovering new types of radiation. We discovered infrared, I think, around 1800, but radio waves and X-rays came around very late 1800s, 1900s, and they discovered alpha rays and beta rays and gamma rays as they started working with radioactive materials. Mm-hmm. So we're thinking of all these new kinds of radiation, and could you make a death ray? Well, that was with all the new technology that was coming around. They were wondering about that. Mm-hmm. So they started experimenting, and as airplanes started getting off the ground, it became clear, and especially once you started getting closer to World War I, rather, you could actually use an airplane to bomb cities. And this really started getting military forces upset. And they started looking around, well, what can we do to shoot down these airplanes? Mm-hmm. And hard to get bullets up there that far in the sky, especially a century ago. Yeah. So they're looking at, well, let's see if we can do this with radio waves. Hey, Marconi and Tesla had been doing things with radio, and can you fire electricity through the air? They didn't know all that much about how this stuff worked then. And they started talking about trying to make a death ray, shoot down airplanes. So there were quite a few, people claiming that they had done that. One of my favorite examples was a fellow named Giulio Olivi in Italy. Mm-hmm. And he had said, had the idea of being able to ignite a mine. And this is the type of mines you'd be using in water, to mine a harbor so that invaders couldn't get in and their ships would blow up. Mm-hmm. He was saying, I have a way that we can mine the harbor, and I will fire this ray, and it will ignite the mine and make it go off. Mm-hmm. He demonstrated that. Well, he demonstrated that with his own mines that he'd made and put in the water himself. And mm-hmm. Here I have my death ray, and see, there it goes. Come on, now, okay, boom. Well, he had a little trick. Yeah, he had a real mine. It had gunpowder or some sort of explosive in it. Mm-hmm. He added a little dash of sodium. And he drilled a little hole in the mine and put something in so that the water would dribble in a little bit. Now, what happens when you have sodium in a landmine that's floating in the ocean and the water starts leaking in? It catches fire. Boom! And the admiral who was in charge of this said, well, this is interesting, but we want to try our own mines to make sure you're not doing something.
Right.
And just to make it more interesting, Olivi fell in love, madly in love, with the admiral's daughter. Now, you can't make this up, So here he is trying to run a scam on the admiral. Well, I don't know that he thought it was admitted scam, but he was doing something funny and fun. And he said he asked the admiral to give him permission to marry his daughter, and the admiral says, "You finish the tests first." So finally, he elopes, and eventually they sort of give up on figure out there's something wrong, something funny going on there. Mm-hmm. So that's one of my favorite stories, just because it was so crazy.
Yeah. Yeah, well, and it's like at this time where people didn't know what was or wasn't possible. So it's like, well, let's try it and see, what's going to happen, right?
That's the idea. It's try
Yeah.
it and see. And the admiral had the right idea. He would just keep testing it, and let's see if if this kind of thing will work.
Hmm.
And there were others. Um, there was a British engineer named Harry Grindle Matthews, and he had been a soldier during the Boer War down in South Africa, where they'd been using very early radio communications that developed by Marconi.
Hmm.
And Grindle Matthews, had gotten fascinated by wireless communications. And when he came back home, he was living with his mother, and he was uh, decided he was going to make a wireless telephone. And here it is, late 1909, and he's
Hmm.
trying a wireless phone.
Right.
So he claimed that was able to get signals a few miles away. He got some people to back him, tried to
Hmm.
start a company. Um, he was going to sell the phones for what was the equivalent of about $500 today. But hey, that in 1909, a wireless phone. Well, this is
Yeah.
amazing. So um, he still didn't get enough customers. He went out. The company went out of business eventually. But he was
Yep.
doing other inventions, and he had some credibility as an inventor. He was able to use wireless guidance of a boat, of a little miniature toy boat, uh, that won a prize of something like 10,000 pounds, which is real, or 1,000 pounds, I forget now which, was real money at the time, uh,
Yeah.
from the British Admiralty. And then he did some other military stuff. And later on, back around 1924, he had an idea. It claimed he had a way to fire death rays through the air. It was some kind of, I think he was using ultraviolet light to make a hole in the air and make it conduct electricity, or this was what he said anyway.
Yeah.
And there's a wonderful video you can see on YouTube if you search for Grindle, Grindell, Matthews, uh, Death Ray.
Hmm.
And you can find there's an 8-minute version that goes on. It's a silent, it goes on, and it's just fun to watch because, and you can see him in that movie. He actually takes off in an airplane because he's trying after the British are getting a little funny about wondering what he's trying to do. He goes over and offers it to France, and then eventually comes back. But this is flying around in an airplane in 1924. That was a big deal.
Hmm.
So this is a serious businessman doing serious inventive things. And the Admiralty after this, well, no, this one didn't work either. And the Admiralty finally figured out, well, um, we've got to have a way to test this, to check these people out. And he decided, well, we'll put a sheep out in a field. And if you can kill it from 100 yards away with your death ray, okay, we'll give you 1,000 pounds, and and the implication was, we'll talk with you more.
Yeah.
This looks like it's going to work.
Hmm.
And needless to say, nobody ever killed the sheep.
Oh man, it's so fun. Like all these little stories about people saying they invented stuff, trying to come up, things are happening and stuff, but then nothing really is taking off or really proving to be successful. But this is also kind of when it really starts to emerge in like kind of science fiction writing and stuff too, isn't it?
Yeah, the first mention of the death ray is in a book and that was made into a silent movie, The Exploits of Elaine.
Hmm.
And what there is, I mean, there is an evil villain whose name I forget at the moment, but he's, the stalking hand or the clutching hand or something like this.
Uh-huh.
There's a Craig Kennedy, who's a professor and a detective, is trying to prevent this, and somehow, and this clutching hand is mad at him and says, "If you uh, don't get off my case, I'll start killing people with this death ray. This is the," and saying in the movie, "This is the one that the Italian Ulivi has made."
Mm-hmm.
Right. He's, the book actually plays on, borrows this bit of news that the author read. And so people walking by in the street by his laboratory drop dead when somebody shoots them with the death ray. And that's kind of how the science fiction death ray got born. I think that's there. I mean, there was some time, certainly if you go back to H.G. Wells with the heat ray of the War in the Worlds.
Mm-hmm.
But that was a little more what I call harder science fiction, because that was real infrared light, and you knew how to make that. You didn't know how the big, powerful death ray, but that was real. And the X-rays and the death rays, the death ray that would kill on contact, which is sort of a science fiction meme that has been played for a century now. That is just more fantasy than science fiction almost.
Mm-hmm.
So it's a then by the actually there's one of the interesting things here is that Hugo Gernsback, who started the first science fiction magazine, Amazing Stories, in 1926, he'd been publishing radio experimenter type magazines or electrical experimenter magazines, and he went through a series of magazines because he kept going broke. And he had articles by Nikola Tesla about how he did things, and Tesla started talking about ways that we could fight World War I, as I recall. How that, and so Tesla had these ideas, and Tesla, of course, had ideas of beaming wireless energy around the world.
Yeah. And he even had he even had wireless energy where he could demonstrate on a stage that he could light up a light bulb and stuff, right?
Oh yeah,
That's incredible.
Yeah, he had a real way of transmitting wireless energy, and that was, it's something you can do. Microwaves, radio waves. You can focus that energy, and you can get it through the air. The problem you have over long distances is it just tends to spread out.
Right.
Because that's the way radio waves work. And to make a special type of antenna that you can kind of beam the energy, but it still spreads out. It's more like a search. At best, you've got something like a big searchlight, not a little powerful laser beam.
I see. Man. Okay, so we're kind of up here. People are working with this stuff and thinking about it, and we have Archimedes doing, that kind of started it all, but it's all sort of like using, as far as the real world, that's using, sunlight that already exists and stuff. But then we kind of start to get into the development of the actual laser in like the 50s or so, right?
Yeah, the 50s, the idea of the laser emerged from what was called the microwave maser, which Charles Towns invented in the early 1950s and demonstrated. Yeah. And it was really, what it really was doing was generating a beam of microwaves, although they were actually more using it as a microwave oscillator to generate sound or generate radio waves for use in radio or radio transmission or directed, somewhat focused radio waves or amplifying weak radio signals that they were picking up. So that was the idea that they were first trying, and Towns had a military contract and to sort of a follow-on of all the radar technology that had been developed during World War II.
Mm-hmm.
And then he started wondering what he could do next. And he went around, and one of the people he was talking with was a grad student named Gordon Gould, who was at this point about in 1957. Gould was a 37-year-old graduate student. He'd been kind of kicking around a while, but he was there at Columbia University, where Townes was, and Gould had been doing something with light. He'd been experimenting with light and using a technique called optical pumping, where you're actually shining light onto something to excite atoms or electrons. And you use a particular wavelength of light to excite a particular type of atom.
Okay.
And that actually won somebody a Nobel Prize, because it was an important term, a tool for spectroscopy to use and for scientific research.
Mm-hmm.
Gould was one of the first people using it here, because one of the professors at Columbia, I. Rabe, came back with this from France and said, here, hey, this is something you can use, Gould. Let's see if you can make something work this way, because Gould's project was going slowly.
Yeah.
And indeed, it worked. And Townes looked at it, and Townes was thinking, well, maybe I could use light to excite a laser. And what he was calling it at the time was an optical maser, a light version of his microwave maser, because the maser, after all, was his invention.
Mm-hmm.
And so Gould, they kind of got talking after a while, for a while about this, and then they sort of wandered away. I mean, this was just also about the time of the Sputnik launch. This was October 1957.
Mm-hmm.
And their notebooks say that Townes had a couple of conversations with Gould, and then Gould kind of dropped out of Columbia, because he thought about this idea himself. And well, Gould's attitude was, well, Townes asked me a question, and I can come up with the answer. So he walked away and started inventing it himself. And he's writing notes in his, chain smoking in his kitchen with a bunch of notepads and slide rule and all the sort of thing that you used in 1957. And he had because Gould had worked with optics, he realized, hey, if you have a pair of mirrors like this, I'm trying to get him into the picture, you can reflect light back and forth. And if they're perfectly flat and perfectly parallel, light will just bounce back and forth. And you can amplify the light and make a beam. And that was, an invention. Townes started working with somebody else. And eventually the two of them came up with that invention. But by the time they came up with that invention, Gould had already, been written it down in his notebook.
Mm-hmm.
Decides he's had it with grad school. He's going to be a rich inventor. He's going to be Thomas Edison. So he starts just obsessing on this whole laser thing, and he has to earn some money. So he goes to work for this defense contractor, and little small defense contractor in New York City. But he's always working on this laser thing. And finally, the boss calls him in. What are you doing? And Gould tells him. And the boss sort of looks. That's interesting. We might be able to get a contract to do this from the Pentagon. Oh, okay.
Mm-hmm.
So they start paying Gould to do this, and he's writing up the patents, and then TRG the company is going to share in the patents because they're paying him. But Gould figures, hey, I still get half of a fortune is as good as a fortune. Why not?
Right.
So he goes in, and they eventually go down to what was ARPA, the Advanced Research Projects Agency. This had just been formed right after the Sputnik launch, because everybody's worried about Soviet nuclear missiles. If you can launch a Sputnik into space, you can launch a bomb and drop it on somebody else on the other side of the world. So this is, how do we stop this? Well, the first head of DARPA, um, a fellow named Roy Johnson, told Congress, well, maybe we can find a death ray. Who knows?
Yeah.
Maybe we can even make a death ray. Maybe that will be the solved problem. Because what if we actually had a speed of light weapon to stop these missiles coming in from all around the world? They could fly around half the world in 30 minutes or 40 minutes. We could stop it with a beam of light. So in walks Gould to ARPA.
Mm-hmm.
And he says he really got these colonels is so excited.
Yeah.
And they were talking about this stuff, and they were physicists, they were scientists. They said, "Hey, this makes sense. This is at least possible in theory.
Mm-hmm.
This is something we ought to try." And so Gould and his boss go back home. They had applied for a $300,000 grant. That was big money back in 1959 by this point.
Yeah.
And so they got a call back from ARPA and saying, "Yeah, we want to do it." And the boss goes back down to ARPA, and he says, "No, well," and I want to make one little change on this. We want to give you $1 million. And nobody does that.
Yeah.
Contract. So okay, everybody's all excited.
Yeah.
And then because hey, this is military, and this is something that's going to be really, gosh, wow, they classified it. And Gould was getting very antsy because the reason he had been knocking around for quite a while was that he actually had worked on the Manhattan Project, and then he'd gotten fired because he and his girlfriend, who was a communist, were protesting things. And then he married her, and then he became a communist himself.
Oh gosh.
And he hadn't told the boss about that little skeleton in the closet.
Right.
And the boss said, "No, I can't imagine they wouldn't give you a clearance to work on your own project."
Mm-hmm.
Well, they wouldn't. and they got hotshot lawyers to go in and try to make him look good. And nope. And then Gould finally, they finally had to put Gould off in a separate building, and they had to knock a hole in the wall so that he could go to build a door to the bathroom that he could access. There's all this
gosh,
ridiculous stuff. But no, so the company didn't make the first laser because Gould was off. Well, actually, he was fooling around with the secretary, but that was another story.
Oh man.
Worse, it was the company security officer he was fooling around. And so they didn't make it. But out in California, Theodore Maiman made the first laser at Hughes Aircraft, which was owned by Howard Hughes, the great mythical bashful billionaire.
Yep.
Who apparently never spoke to anybody in Hughes research labs, and Maiman never saw him, and nobody ever saw him.
Oh wow.
Which takes us a bit away from lasers and death rays, but that's how the laser was born.
Yeah. So okay, so how did Ted Maiman how did it happen for him? How did he get involved?
Well, the idea, Towns and Arthur Shallow had published a paper about how to make a laser.
Mm-hmm.
And the idea was floating around, and Maiman had been working with microwave masers made of ruby, and he knew the material, and he decided, this looks interesting. And people were saying, no, it won't work, but he couldn't figure out why it wouldn't work. And he decided he'd try the ruby and just try a simple experiment. It didn't have to be a big, powerful thing. He got his assistant, Charlie Asawa, said, hey, somebody had this big photographic flash lamp. Why don't you try this? And
Mhm.
there was one with a coil, so they just stuck a little ruby rod into the coil of the flash lamp and put a big high voltage source onto the flash lamp and started firing it, and with mirrors on each end,
Uh-huh.
and it worked. It was a flashes of red light, spots of red light on the wall, uh, and then they went and gave a press conference on it, announcing that this was a big deal to Hughes.
Yeah.
And they got on the front page of the New York Times. And they got on the front pages of some other papers too. And Maiman came back and he recalled many years later when he wrote his autobiography that he saw these, flew back to Los Angeles from New York where they gave the press conferences. And he looks at the newsstands and there's various headlines in 2-inch red type saying LA man builds death ray. And in fact, when he had given the press conference, the reporters had come up and said, "How can you build a death ray?"
Mhm.
Well, can you rule it out? Well, no, I can't really rule it out.
Mhm.
Made this thing, it's just little flashes of light right now, but maybe it could. So of course it's headlines.
Yep, of course.
Uh,
Man, so okay, so Maiman is he sort of considered the inventor of the laser then?
um, May Towns won the Nobel Prize for the idea of the laser and the concept.
Uh-huh.
Maiman made the first laser
Okay.
and invented the ruby laser. And Gould also had the concept and some of the idea. Gould ended up finally in the 1980s. His patent was hung up in courts for years, and finally in the 1980s he got his patent and sued people and made millions of dollars off the patent.
Mm-hmm.
So Gould
Right.
got rich. Um, Maiman had made the first laser and was a little annoyed that other people were considered to have invented it.
Yeah.
And Towns got the Nobel Prize. So,
Okay. Kind of kind of all sharing it, I guess.
yeah, yeah.
Interesting. Okay, so what can you just kind of give me maybe like an overview layman kind of you know idea of how a laser works?
Well, what you're doing in a laser is it's called light amplification by the stimulated emission of radiation. And
Uh-huh.
what you're doing is you're taking some form of energy and exciting atoms, or exciting electrons in the atoms to a high energy state where they'll
Mm-hmm.
emit light. And because you put them between a pair of mirrors, and generally at least one of the mirrors will reflect all the light and the other will reflect some of it, and the light it'll start emitting inside, light emitting, it'll go bouncing back and forth between the mirrors and build up to be a beam you could see on the wall, a spot on the wall, or
Huh.
more powerfully, something, a big bright beam that can burn a whole little hole through a sheet of foil or a piece of wood, or eventually, something more substantial.
Mm-hmm.
And but the idea is you're concentrating that energy from, some source, like from a chemical reaction or from pump light around it, like, the flash lamp that Maiman used
Mm-hmm.
to uh, to make a beam. So you're concentrating energy from around you and a flash lamp has a big amount of energy, a bright flash of energy. You concentrate it all in a spot, maybe you could burn a little hole in things.
Mm-hmm.
And that's the idea of a laser, is you're concentrating the energy. And one of the tricks of doing this also is to store the energy for a while, so that you'll have the light on for a while, and the light won't actually go out of the uh, laser that laser cavity you have until you switch open, allow the light to get out by, let's say, taking a piece of the mirror and opening it up like that. Imagine that.
Okay.
So that's the idea of this.
Mm-hmm.
The first lasers were very weak. You also can have lasers that just emit a steady beam, or you can have lasers that accumulate a lot of energy and then fire a pulse out.
Oh, okay.
That's what got to interest the military is, hey, we can, just crank it up and then bang.
Yeah.
So,
interesting. Okay. Kind of like a Star Wars laser gun type of thing, huh?
Yeah, and the Pentagon was talking to Mayman, and he was got a contract to start, making lasers and experimenting with them, and other people did, and pretty soon there was a lot of hype about lasers and weapons, and there was I think it was Parade magazine had an article, "The Incredible Laser," and that was really pretty far out on all these. So Art Shallow, who was worked with Charles Towns, put up a little sign, and Shallow was a jokester and rather a playful scientist. So he put up in his door a sign saying, he put the copy of the Parade article about the incredible laser on his door, and beside it put a little sign that said, "For credible lasers, see inside."
Oh, that's good.
So that was Art Shallow. But by this point, the Pentagon was starting to throw serious money into this. So there was General Curtis LeMay was talking about, hey, this is a wonderful invention. And saying this is now the greatest thing since sliced bread or whatever. Except it turns out if you try to slice bread with a laser, you just get burnt toast. But that's another story.
Oh man. Wow. So this is cool. You can kind of see the evolution of it and how it happens. But when they're kind of doing this well, I guess one question I had real quick was, does the word laser come from maser?
It comes from light amplification of the stimulated emission of radiation.
Oh, okay.
It is that was Gordon Gould's term, laser. He says light, obviously cribbing a little bit from microwave amplification, but light amplification by the stimulated emission of radiation.
Okay, makes sense.
Gould, and then there was a little, Gould and Towns sort of thought about who would win the name, but Towns won the Nobel Prize. They used Gould's name.
Oh boy. Okay, but so when they're kind of developing a laser and everything and figuring this stuff out, are they mostly thinking of sort of weaponizing it, or are they thinking of the other possibilities of what it could be used for?
That actually, they started thinking of using a laser as a rangefinder. Or, you fire pulses, or you'd use it or you'd shine a laser beam onto a target, and then have a missile home in on the bright spot.
Okay.
And those type of weapons were actually used in the Vietnam War later on laser target ranging, they call it target designation, where you'd have somebody shining a laser spot onto the target, out wherever he's, shooting it. Of course, that meant he had to kind of poke his head up enough to see the airplane or the tank they were designating. So it was not perfect from the soldier's viewpoint, but it was a usable weapon, and it was used in the Vietnam War like that. But that's, just as a way, because what you have is you'd have sensors in it that would home in on that bright spot, that colored bright spot. It would be red for ruby, and then they had infrared for another from light from neodymium that you could home in on. And the infrared spot, nobody knew they were getting designated with that invisible light until something came at them.
Okay, that makes sense. And then, so how did you get different colors of lasers? Is that just the different wavelengths?
That's different. That's from different energy transitions within light. Say if you have red, well, ruby, which has chromium in it,
Uh-huh.
emits red light, and ruby was the first laser that Maiman made,
Mm-hmm.
uh, and it will emit, it'll store up energy from light and then emit it as red light,
Okay.
and that's how you got that color. And different atoms would emit different colors. You can have neon will emit red light. You have trying to remember a good well now there's other semiconductor materials that emit uh, red, green light or blue light.
Mm-hmm.
So there's a lot of different colors. It's just depend. It happens that ruby, for example, it was a good material, and
Yeah.
there's a rare earth called neodymium. That turns out to be a very good material emitting infrared light.
Oh, okay.
So there's it depends on it depends on the energy transmissions, energy transitions between energy states of the atom, and you want to store a whole bunch of things up in this high energy level,
Mm-hmm.
and then let them all emit light or burst at once.
Oh, okay.
That's the idea of it,
Yeah.
and
Okay.
you have it because between mirrors, and you focus it into a nice tight line.
Yeah. Okay. That's understandable. I can get that. Okay, cool. So we have this going, and then the rocket engine laser kind of comes along, doesn't it?
Yeah, yeah. This is uh, there's some guys at this place called Avco Everett Research Laboratory, and they're a military lab,
Uh-huh.
and they're trying to find ways to use lasers to shoot down missiles because
Yep.
this is the mid 1960s. We're all worried about nuclear missiles, you know, and Kingdom Come, getting blown to Kingdom Come. So what they're trying to find is something to shoot down missiles at a distance,
Mm-hmm.
and and they more or less figure out that, hey, suppose you can that they've got a way of if they have a way of exciting atoms to a state, if they can emit enough light, then they could burn holes in things. And uh, they finally start looking at chemical reactions. And so you excite, let's say you're have rocket fuel, and it's burning. You're getting very excited atoms from a chemical reaction. So you
Mm-hmm.
get molecules that are and they'll emit light. You'll see them burning. So let's say you have hydrogen and fluorine, and that turns out to be what actually they would use in some of these lasers is
Mm-hmm.
hydrogen fluorine to make hydrogen fluoride. And that releases a lot of energy. And so these guys at Avco Everett Research Laboratory figure out, hey, maybe we could make a chemical laser. We'll have these chemical reactions, and the chemicals will emit light when you have a hydrogen and fluorine uh, hydrogen atom and a fluorine atom come together, and you actually are burning hydrogen molecules and fluorine molecules, and they're making hydrogen fluoride. It has lots of energy that emits in the infrared.
Uh-huh.
Uh, so, and you're so well. It's kind of like a rocket engine. In fact, it is pretty much a rocket engine. You burn
Uh-huh.
something like that, and you're pushing the fuels through it, and they're igniting. All you had to do was Ed Gary, who was working there, um, was one of the inventors of this laser. He and
Mm-hmm.
Anderowitz figured out, hey, if we can get just a tenth of 1% of the energy out of this rocket is burned. This is rocket fuel. This is what this stuff is.
Yeah.
It's rocket fuel. And hey, where all this flame is going out the end. And if we can get some of this to make light, we can extract the light from that. If all we need is a tenth of 1%, and we'll have because rockets are so powerful, we'll have 1,000,000 watts of light. And we can burn holes in things with 1,000,000 watts of light.
Yeah.
So this is the idea. So they tried making hydrogen and fluorine, and it worked. It worked. It didn't quite get up to 1,000,000 watts, but they got up to 20 kilo. I think they realized they had something when they got up to 20 kilowatts, because nobody got more than about 200 watts before out of it.
Wow.
And so they've got this thing. Oh man, we can burn holes in things.
Right.
And that was, it was basically running like a rocket engine. It kind of was acting like a rocket engine, but they're getting light out the end. You stop and look at a rocket engine, and there's light coming out of it. Well, this was designed to collect more of the light than the energy,
Mm-hmm.
and it produced a lot of heat as well. But hey, if you're trying, this is how you could make, 10 kilowatt, 20 kilowatt, hundreds of kilowatts, maybe. Wow, we can get up to a megawatt.
Yeah.
So they're all excited about this, and they start working with these hydrogen fluoride lasers and hydrogen fluoride lasers
Uh-huh.
things, and it's all super super secret.
Right.
Except
Of course.
out too, and eventually they started talking about it, so we started talking about it. And then okay, they finally got decided to try to build an airborne laser.
Mm-hmm.
Put it up in a plane. Hey, look at this. They got up in an airplane, and we can shoot all sorts of things down in the airplane if we
Right.
put this rocket fuel. And well, it turns out it wasn't that simple. You get all kinds of vibrations when you're flying around in the plane,
Mm-hmm.
and things sag, and they couldn't hit the broadside of a barn, basically. But they, eventually, and they were trying to shoot down targets, and eventually they managed to shoot down a few. But it was basically just a big rocket engine firing.
Yeah.
That's what it was, and it was pretty much that. Instead of getting the flame out of the rocket engine, you're getting a beam of light. It was a pretty powerful beam of light.
Yeah.
But then you had they also had what they called the fires of the week, because they were, these things would, you're burning hydrogen, you're burning fluorine. These things are pretty combustible. So they had, the fire of I heard people talking about the fire of the week.
Jeez. Man, oh man. Okay, so they kind of get this going. Is really just the thing that kind of holds it back is just the fact that they can't really aim it properly?
Well, it's really hard to control.
Mm-hmm.
You've got flowing gases, hydrogen. You're starting with more or less hydrogen and fluorine, and hydrogen is pretty flammable. Fluorine's a lot worse, and it just wasn't very controllable.
Okay.
And that was the thing, and you want. You also had the problem that hydrogen and fluorine, when you burn them, that light tends to get absorbed by the atmosphere. It's all in a part of the atmosphere that is where light is absorbed. So then you could use deuterium, which is the heavy isotope of hydrogen, but there's not very much of it, and it's expensive.
Oh.
That would emit light at a different wavelength, so it would get through the air a little better. But it really wasn't, a very good weapon.
Mm-hmm.
And they really didn't have all the technology they needed to play with it. So they shot it. They fired it off They invited the press to come and see it in 1981, January of 1981. It was, Carter administration was coming to an end, and they wanted to show that they'd actually done something with lasers, and it didn't work. I talked, and then they did another one, and they did another one a little bit later on, and it didn't work. And I
man.
called up a colonel I knew, and I said, "When are we going to hear anything more about this?" He said, "You won't hear anything more until we shot something down." Because they hadn't been, they had a beam, but it wasn't enough to it wasn't tightly focused enough to shoot something down.
Yes. Okay.
So, yeah. And then in 1983, they finally did shoot something down.
Oh, okay.
Yeah.
Finally got it to work, huh?
Yep. Who knows how many millions of dollars it took to shoot down that target? But
yeah, really. Yeah, it's true. Jeez, man. Okay, so like, so how have things progressed since then? Like, where are we kind of at today with this technology and laser weapons or anything like that?
Well, there have been a couple of later tests. There's one called the Airborne Laser Laboratory. There was that. I'm sorry, that was the first one, the Airborne Laser Laboratory. There was the Airborne Laser, and there was a lot of interest in laser weapons during Reagan's Star Wars program. But the fact was, the technology really wasn't very, very ready. They had worked on something called Alpha that was supposed to generate megawatts, millions of watts. And they kind of got up to that, but it was more or less like a torch. It wasn't very well focused. They did, produce high powers, but it wasn't really, it just wasn't focusable. And they had the airborne let's see, so they decided eventually to start the airborne laser program, which was basically a 7.4. The airborne laser, which was the first one they tried, was a 707. This was a 747 with more chemicals and more lasers.
Right.
And that finally shot something down in 2010. About 5-10 years behind schedule. They had a lot of problems with it, but they got a good quality, reasonable quality beam out of it. And they actually shot something down. But by that time, it had become pretty clear that these rocket engine lasers, these chemical lasers, where it's basically just pretty much like a rocket. You're pushing fuel through and burning stuff and emitting light. And the way that you have mirrors on the thing means that you get the light out in a reasonably focused beam.
Right.
But this had a lot of problems, and they tried using it. They also was a program in the 1990s to work on trying to shoot down rockets, artillery, and missiles with the Israelis, because they were worried about rockets being shot at them. And the problem they had there. Excuse me as I get over the water here. The problem that they had there was it could work. They had some test, so fairly simple laser that could work. It should make 100 kilowatts of light, and it could shoot down targets. Now, the big difference now from during the Reagan era, they were trying to shoot down missiles, let's say 5,000 kilometers away. They're trying to shoot down ICBMs, at long range. This was part of Reagan Star Wars, key part of Reagan Star Wars program.
Right.
And it didn't work because you couldn't really get the beam 5,000 kilometers away. You needed lots and lots of power, and the beam broke up. So what they were doing with these experiments with this shorter range laser, it was just shooting, a few kilometers away. So this was much easier to aim at. You didn't
Mm-hmm.
beam dispersing, uh, but you still had all these chemicals in it.
Yeah.
And so they had shot down some rockets, artillery, and mortars. Okay, now we've really got something that works. It's short range. It's on the order of a kilometer away. That's not that far. If you're starting out with 100 kilowatts of light, and you've got it in some kind of beam, and you're shooting it especially at something that's loaded with explosives, so that all you have to do, you don't have to bang a hole in it, you have to heat it up enough that the explosive inside catches fire.
Right.
Okay, so this works. Uh, so the Pentagon came in, and they had their uh, people who were really, in charge of getting weapons to work. These are the not just, they don't work in the lab. They work. Their purpose is to build weapons and design weapons and make sure everything will work. And they came in, and they're the logistics guys, and they came in and said, uh, what do you need? How do you make this work? And they said, well, here, we've got this chemical over here that makes fluorine, and we've got this chemical over here that makes hydrogen, and then we mix them together. And the logistics guys looked at them and they said, wait a minute. If you don't have any of this chemical, you have a piece of junk. If you don't have any of that chemical, you have a piece of junk. We don't want any more chemicals on our battlefield. We want something that will run on diesel fuel.
Oh.
Come back and to show us a laser that will run on diesel fuel, and can you do this? And we love it.
Huh.
Oh, this will be great. But no, we don't want chemical weapons on the battlefield.
Mm-hmm.
Hydrogen fluoride is a chemical weapon.
Yeah.
They'll get asphyxiated by it on this, the troops will, or you get blown up. So we want us, and we want a different kind. We want a laser that can run on diesel, or run on light, be powered somehow directly by light. All we want is a box that something here that you feed diesel into, and light of a laser beam comes out.
Mm-hmm.
Back to the drawing board.
Yeah.
And fortuitously, there was at this point, we're at this point, other lasers that had come on, and one of the technology, well, there's a whole set of solid state laser technologies, and what you also can use semiconductors to emit light. Now, semiconductor lasers have an important property. They're they can turn electricity into energy pretty efficiently, like 10 or 20 or maybe even 50% of the electricity that goes into a semiconductor laser
Mm-hmm.
emerges as a laser, as light. So that's, this is what you want, something that's efficient, because they've gotten up above the 1/10% of the first chemical lasers, but they were still inefficient. Chemical lasers were inefficient.
Yeah.
So something that would turn energy into light, and then the light could pump the laser. And the semiconductor was taking electricity, turning electricity into light, and that electricity then could go power the laser. You couldn't use the semiconductor as a powerful laser because the semiconductors, you had to they were small, and the beams, and because they were small, the beams spread out widely,
Oh.
and so you couldn't really use them. You needed something that would focus a beam that would go a kilometer or kilometers, just
Mm-hmm.
miles, not, you didn't want something that spread out, like a cheap flashlight.
Right.
So this is what you needed. And fortunately, the semiconductor lasers had been made quite powerful. And then they figured, okay, you can use a semiconductor laser to power another laser. Because light can power a laser. That was what happened in the first the ruby laser that Maimon made. It was light from another light, so from flash lamps that
Mm-hmm.
excited the ruby, which is the active element of it, and there was excited the chromium atoms in the ruby, so they emitted red light. So now let's see, okay, we can take this semiconductor and we can excite atoms in something, and let's say ruby, let's say neodymium, which is a rare earth element, and it actually emits invisible infrared light. But that was, a powerful, had made powerful solid state lasers before. So then you get this, can make by that two-step process, you can make something that gets maybe 10% of, that turns 10 or 20 or 30 or 40% of the energy into light. And that's a lot of energy. So,
Uh-huh.
okay. So they went and tried to do it, and had, about 10 years, it took them about 10 years from 2000 until 2009, and they had 100 kilowatt solid state laser
Mm-hmm.
that operated for 5 minutes at a time. That's enough to burn a respectable hole through things.
Yeah.
And you couldn't see the light, but hey, you don't have to see the light. In
Yeah.
fact, that turns out to be where things are good. So this was a major step forward,
Mm-hmm.
and then they had to make it a little more practical device, because this was something that required a lot of cooling, among
Mm-hmm.
other things. So they ended up using optical fibers that were, very thin fiber,
Uh-huh.
could convert pump light from the semiconductors, which are what the little diode lasers, like the little diode lasers you have in a laser pointer.
Uh-huh.
Though there's different versions of those that emit at different wavelengths that can emit high power, and they excite atoms that are in glass. You might use ruby, but what they use is just glass,
Mm-hmm.
and in the center of the fiber, and it emits light that comes out of it. And it turns out it's quite efficient. The fiber is limited in how much power, but then you get a bunch of fibers together, and you make them into a fiber laser. And that's actually what they're using right now. The technology they're testing is optical fiber lasers,
Huh.
uh, and it's, you get 20-30% efficiency. They're going for 40% efficiency.
Wow.
And that's really, really efficient, because you look at your old fashioned uh, electric light bulb, and that was nowhere near that efficient in turning electricity into light.
Huh. Man. Cool.
So
So that's kind of where we're at today and what we're working with today and improving on.
that's what's going on right now. And there's a whole
Mm-hmm.
bunch of test beds out there now that have been tested. Uh,
Right.
in they put them in a plane. They've got them on the ground, and they're 60 to 100 kilowatts now. And they've got them in trucks and things like that. So it's a these are uh, the giggle factor is gone in that sense. It's no longer quite as crazy as it looked. There's still
Mm-hmm.
still a lot of issues to make, but what they're shooting at now, are rockets, artillery, and mortars from terrorists. They're also looking at ways you can defend ships, because they're uh, are people with terrorists with little small boats will try to go out and shoot at them.
Right.
So shoot missiles at them. So you just go shoot back at them and take them out.
Yeah.
So
Man.
Yeah.
Interesting. Yeah, that's cool that that's going on today still. Like they're still really working on this same kind of, weapon ideas they had so long ago.
Yeah. And it's, in a sense, it's no longer real. It's not easy. There's a lot of difficulty. And the whole mission they're taking on now and shooting at, what essentially are terrorists or, in the near term or insurgents, this is, you're shooting at things a few miles away at most. And
Hmm.
that's a lot easier than where you're having to shoot through a lot of atmosphere because the air gets in the way.
Yes.
Uh, and you don't have to absorb a lot of light before if you were absorbing a tenth of a percent a mile, um, or let's say 1% a mile, that builds up if you're shooting through the atmosphere,
Right.
and it also makes the air expand, so that defocuses the light.
Oh, okay.
So there's other kinds of things you have to do to make sure you get the light focused.
Hmm.
So it's there's a lot of engineering to do on this.
Yeah. Whew. Crazy. What's also cool in that is that it's, this stuff is going on for weapons, but the laser is used so much in just like our everyday kind of consumer products with like CD players and well, fiber optics, like we just for internet and stuff. It's crazy.
Yeah, we're talking through fiber. We're talking through fiber all the way from my home. I
Yeah,
don't know if you've got it, but I've got it
I
in the
kind of
house.
too. Yeah,
Yeah,
it's awesome. I love it. Yeah.
yeah. So this, we're getting all this bandwidth,
Yeah.
and it's not all a spin-off of military stuff. There's a tremendous number of peaceful applications for lasers. There's
Hmm.
and you can use these things for materials working, for cutting and welding. It's a billion-dollar business to use lasers for machine tools.
Yeah.
I think there's $1 billion in laser medicine.
Yeah.
And it's really amazing. And this is sort of the gosh wow stuff that there's other kinds of things that are just it's like you don't see the fibers in the outside, the optical fibers. This is all this light's going through glass, guided through glass.
Yeah. Yeah. So what does the fiber optic cable look like? How does that work?
uh it looks, well, it's a hair thin fiber of glass. I probably
Oh,
some if I look around in my office, but it's just a hair thin piece of glass.
man.
It's there's I can't pull out the fiber in the wall,
Yeah.
but it's just like an ordinary cable.
Right.
Looks like an ordinary cable, but it can carry gigabits
Hmm.
or of data, billions of bits per second.
Yeah.
And this is it's revolutionized telecommunications.
Hmm.
The uh, Back in the 1950s, there was a whole generation of technology that was developed that for millimeter wave guides, things like this, that more or less got blown away when fiber optics and lasers were invented. Because the other thing with fiber optics is the glass if you use pure silica, the glass can be so pure that you can go hundreds of miles. And there's still there you can go over 100 miles and there's still light,
Yeah.
little amounts of light.
Whew. So cool.
So it's all uh, it's an amazing technology.
Yeah. So I have a question about, just kind of when I'm looking, like maybe with just laser pointers, like one laser pointer will shoot and it will just kind of show a dot, little red dot or something at whatever I'm pointing at. But then there's other ones that I can see the whole beam. What's the difference between those?
Well, what the difference? One difference between those is how dusty the air is.
Oh, okay.
Doing is really scattering off the air. Light is scattered off the air, and if you have a laser pointer and
Uh-huh.
get out and let's say take a piece of a couple of erasers full of chalk, go bang bang, make a little dust cloud, and take your laser pointer, and you'll see all the little sparkles.
Oh, okay.
That and that's how the laser it doesn't light doesn't go through, but it does. You can see it like that.
Okay, that makes sense.
You if you shine a green laser pointer through a shower, you see all the little sparkles where the raindrops pass through it.
Mm-hmm.
Focus it. So
Yeah.
that's that's what's going on there. It's
Just show, yeah, that makes sense. I Man, well, Jeff, this is cool. I love this stuff, especially with the whole history of this, with related to sci-fi, and then how it's actually became a reality and stuff. This is really fun talking to you. So thank you, Jeff.
well, I'm glad to. It's a pleasure. It's a fun story,
Yeah,
uh,
totally.
and it's a fascinating technology.
Mm-hmm.
I really enjoyed working with lasers. I discovered them when I discovered them as an undergraduate at Caltech,
Uh-huh.
and that was not a ripe time. I had to get out and work around. But then I came back and got to work for Laser Magazine, which beat
Mm-hmm.
that a lot of writing computer manuals.
Oh, okay.
Yeah, and a lot more fun. And I've had a lot more fun ever since.
Mm-hmm.
You've got little desk, a few desk laser pointers in my desk and things like that.
Yeah.
It's all, and it's really amazing how far this technology has come.
Mm-hmm. Totally. So what do you think is the future of it? Are we just gonna keep developing it to get better, where maybe eventually we'll be able to make something that can shoot hundreds of kilometers, or is that not really a concern?
Well, there's a lot of things that are being done with lasers that are well more peaceful than that for one.
Yeah.
But you can control light down to a very narrow range of wavelengths. You can get incredible amounts of information through a single optical fiber,
Yeah.
and that's you know it's just incredible. What are they up to? There are up to terabits per second in a single fiber, not billions, trillions of bits per second through single optical fibers.
Man.
They're you can carry all conversation. I think I calculated at one point you could carry hundreds of 100 million telephone conversations, let's say, through a
Uh-huh.
optical fiber carrying multiple wavelengths of light. And it's just amazing. And there's things that we do in spectroscopy and measurement and laser surgery, um, and all kinds of very sophisticated measurements
Mm-hmm.
that it's just amazing. I have to go back and reset my brain almost to start talking through all those kind of things that lasers can do, because it is it's just a tool. You've gotten just amount I'm crazy. It's just an amazing technology, because
Yeah.
you can do all this with light. And light and electronics together have really you know given us this whole power of computing and uh, data processing and signal processing. uh,
Mm-hmm.
so it's just an amazing world. And the growth rate of these technologies, where you started talking about telephone calls worth of conversation, and that, or early on it was just single bits per second, and now terabits per second.
Yeah.
It's amazing.
Yep. Totally. Whew, man. Well, Jeff, we got your book, Lasers, Death Rays, and the Long, Strange Quest for the Ultimate Weapon. That's on Amazon, so I'll have a link for that. Is there anywhere else you want to send people?
Well, where else could you? There's lots of places. I have my own website, jeffhecht.com.
Mm-hmm.
And I write for a magazine called Laser Focus World, which is an industry magazine, and you'll see a lot of things there that you would never understand because it's really high tech, but you'll
Mm-hmm.
also see interesting things that, hey, this is something neat we can do with laser medicine, for example. There's just, lots of technology out there that I've written a book called Understanding Lasers.
Mm-hmm.
That came out at the same time as this. That's the fourth edition of Understanding Lasers,
Oh, okay.
and which is more aimed at, let's say, serious high school student, college, technician.
Mm-hmm.
Tells about how all this stuff works, because there's a lot of very interesting technology in there, and all the things that you can do with it. Spectroscopy, we can do spectroscopy. Look at all that tells what's going on in other stars.
Yeah.
You sort and measure things with light with exacting precision. It's it just boggles the mind, really.
Yeah. Yeah. It is extremely cool how this one technology and invention sort of led to so much stuff and has so many uses. It's really interesting.
It's a true breakthrough.
Yeah.
It's true breakthrough. Electronics is a true breakthrough. Many of these technologies are synergistic because once you put them together, you can do more.
Mm-hmm.
You
Totally.
and that lets you do, as well as you could have light shows. You could have fun with light.
Yep. Yeah, the laser shows. Yeah, totally, huh?
Yeah.
Oh, man. Well, yeah, thanks again, Jeff. Appreciate your time. We'll have links to all that stuff so people can, check it out and learn some more and get your book and everything like that. But yeah, thanks for taking the time, Jeff. Really appreciate it.
It's been a pleasure. Thank you very
Awesome.
much.
Yep.